Hello everybody, this lesson is with multiplying rational expressions. To multiply rational expressions, you can either multiply everything horizontally and then simplify your denominator, so simplifying the numerator and denominator. So for the coefficients, factor out what's in common, and then the variables, you would simplify what's in common. Or you could simplify everything before you actually multiply. So this example here is showing to divide out those common factors in the numerator and denominator before you actually multiply. So in our original problem, in this example, they're factoring out the 2 with this 4. So the 2 with the 4, you've got a 2 remaining here. And then with our x's, there's an x in the numerator and 3 x's in the denominator. So if you cross off what's in common, you'd be left with a 2 in your denominator. I'm going to show this quick. So the 2 crossed off with the 4, you've got a 2 left over. If you simplify the x's, there's an x in the numerator and there's 3 x's in the denominator, so you'd have 2 left over. Y squared, and then a y over here, there's also a y here. These two y's actually cancel out. And then with our 9 and our 3, they share a factor of 3. So this 3 cancels off with a 3 on the top. And then your last step is just to combine everything that's left. So in the numerator, we still have a y squared, and we still have a 3. So that would give us 3y squared. In our denominator, this 3 canceled out. We still had a 2. And then we still have an x squared. So there's that simplified answer. The other method, like I mentioned, is just multiplying everything first and then simplifying. So 2 times 9 to get 18. X times no x here, we just have an x in our numerator. Y squared times y, we get y cubed. So our new numerator is 18xy cubed. In the denominator, 3 times 4, we get 12. And then x cubed y, we still have that x cubed y. And this step here is just showing when you've got variables with exponents and they're divided, you subtract those exponents. So 1 minus 3 gets us this negative 2. 3 minus 1 gets us a positive 2. Whenever you've got this negative exponent, it goes in the denominator. And then the 18/12 simplifies to 3/2. A little bit easier way of thinking about this, if you take this problem here, so 18xy cubed over 12x cubed y, so simplifying our numerator and our denominator coefficients, they both shared a 6. So if we divide out a 6 from each of those, 18 divided by 6, we have 3. 12 divided by 6, we've got that 2. And then for the rest of it, though, think of it as there's 1 x in our numerator, there's 3 x's in our denominator. So this 1x would cancel off with one of these, and you've got 2 left over. So you've got x squared in our denominator. And then there's 3 y's in our numerator and 1 y in our denominator. So this 1y cancels off with one of these, and you've got 2 left over. So you've got y squared in the top. You'll get to the same answer if you actually subtract out those exponents, but sometimes it's easier to think of those exponents as being the number of those variables. So for example, y squared would mean there's 2 y's in the numerator. X squared means there's 2 x's for our denominator. Looking at another example, again, you can multiply everything, so multiplying horizontally for each of these and then simplifying, or just cross off what's in common to begin with. So in my numerator here, I have a 12 and a 3 in the denominator. This 3 would cancel off with a 3 in the 12, and you would be left with a 4. Looking at my y to the 5th, I have y to the 5th, and in my denominators, I have a y to the 4th. There's 4 y's in our denominator and 5 y's in our numerator. So all of these would cancel out, and and you'd be left with 1y in our numerator. So if you kind of start by writing it, we had a 4 and we had a y. This 6 is still there, so I'm still going to show that that's multiplying by 6. And then our x is x to the 10th over x. There's 1x here and 10 here. This one would simplify or cross off with one of these, and you'd have 9 left over. So x to the 9th. And then the last step, this 4 and this 6 can multiply together. This could actually equal 4 times 6, so 24, x to the 9th, and then y. And I just flip-flop the order of these. Typically in standard form, you're going to list your variables alphabetically. So the x comes before y, so that's why I changed it to be listed like this. If you multiplied horizontally, so 12 times 6, you'd have 72 x to the 10th, y to the 5th, over 3, and then 1x and 1y to the 4th, so x, y to the 4th. If it's easier to simplify this way, certainly do that, because 27 over 3 would simplify to 24. X to the 10th over x, there's our x to the 9th, and then y to the 5th over y to the 4th. Think of it as 4 on the bottom, 5 on top, so y would be in our answer. Notice we get the same answer. And then the last part of this lesson, with identifying the domain, it's similar to when we identified the restricted values in our denominator. We need to identify the values that would make that denominator equal to 0, because you can't divide by 0. So we have to figure out what issues we'd have, what numbers would cause our denominator to equal 0. And you want to find those values before you cross anything out. So do that as your first step. So in this example, looking at our denominator, you're going to want to factor this out first. So this 4v minus 8 over 20 times 5v plus 10, factor this v squared minus 4. I recognize this is a difference of squares pattern. Difference of squares pattern always factors to the square root of each of those, so v and 2. And one is going to be v plus 2. The other is always v minus 2. So difference of squares means you're subtracting two perfect squares. It'll always factor with 1 plus and 1 minus. So now thinking about what v would have to be to cause these two chunks equal 0, you can just set it up so that you've got v plus 2 equals 0. So if you subtracted 2, one value for v that would cause it to equal 0 is negative 2. The other one, v minus 2 equals 0. If you added 2, v would end up equaling 2. So the two values, the two restricted values that you cannot have for v cannot equal 2 or a negative 2. So this is what that means. You have to figure out what those values are that it can't equal. And then for the rest of this problem, you're factoring out the numerators and denominators. So the denominator here we've already factored. So over here, if we factor this, they both share, these two terms share a 4. So if I divide out a 4, I would have 4 and then v minus 2 over 20. In this numerator, both share a 5. So if I divide out a 5 from this term and a 5 from that term, I'd be left with v plus 2 all over v plus 2, v minus 2. Now everything is completely factored out. I can cross off what's in common. So this v minus 2 would cross off with this v minus 2. Keep the entire term grouped. If it's in the parentheses, keep it grouped that way. And then this v plus 2 factors with this v plus 2. And then 4 times 5 is actually 20, so that factors out with this 20. So this one simplifies down to 1. One thing that I know students will often do is they'll see, oh, this is a 4. They'll cross it off with this 20 right away. You can't do that. to keep these grouped. When they're separated out by addition or subtraction, keep those terms grouped or you'll end up with the wrong answer. So keep them as group terms, factor them. So we factored by greatest common factor for both of these two, and this one we factored using difference of squares. Factor everything first and then cross off what's in common. So let's look at one more example with this. I have, this one is 12 minus x, x squared plus 7x, and then x squared minus 12x. Again, keep all of these grouped first. And then we want to identify our restricted values. So for our restricted values, we want to factor the denominators. So this one, since it's a minus 35, I need the two factors that multiply to equal negative 35, but add to equal 2. So x minus 5, x plus 7. Think of it as foiling backwards. This other example, x squared minus 12x, if I factor out an x, I'd have x and then x minus 12. So these are my three values. This one, if x equals a positive 5, so x can't equal a positive 5. If x were a negative 7, it would cause that one to equal 0. If x equaled 0, and then x minus 12, so x can't equal 12. So this one has 4 restricted values. So once you've got them factored out, or you found those restricted values, now we can simplify this problem. So this one we had 12 minus x, and this one x squared plus 7x. They both share an x. I'm going to divide out an x. So this then simplifies to x plus 7. Now if we continue simplifying, this x cancels off with this x. This x plus 7 cancels off with this x plus 7. And then looking at these, this 12 minus x is not actually the same as x minus 12, but we might be able to have it look like that. So if you think of 12 minus x, if you reorder those to be negative x plus 12, now they're in the same order. I've got my x term and my 12 next. Over here, my x term and then my 12 next. If you divide out a negative from each of these, so divide out a negative 1, this would simplify. So negative x divided by 1 is a positive x. 12 divided by negative 1 is a negative 12. Now it matches with that one. So if I just rewrite what we had and replace it with this, negative, and then x minus 12 over x minus 5 times 1 over x minus 12. We can now cross off these two terms because they actually match. So this one crosses off with this one. You're left with a negative 1 in our numerator and then x minus 5 in our denominator. So if your terms look similar, this one looked similar to this one, they weren't exactly the same, check and see if you can divide out a negative to make them match so that they cross out, so that your answer is in the most simplified form.